In this tips and tricks episode, we're going to look at how to use Forest Pack's surface tools to quickly populate entire scenes with basic ecosystems that adapt according to the elevation. In the process, we'll share 11 tips for creating this lake scene that can be applied to scattering geometry and optimizing renders to create similar environments. First of all, when working with very large terrains, it's often easier and faster to use a small section of the landscape to help set up the Forest Pack objects that will define the ecosystem. Go to the top view and draw a spline that overlaps a part of the terrain that represents more or less the full altitude range. I've included the island in this example because that's an important part of the composition. Then move the spline so that it's above the terrain and go to the Utilities tab. Open the glue utility. If you don't have glue, you can download it from the ITOOSOFT website. Use glue's base object picker to select the existing terrain object. If you want to follow the terrain more accurately, increase the interpolate by steps value. This will add more vertices to the spline before projecting it onto the terrain. Press glue selected to conform the spline. Now we need to turn this spline into a surface that Forest Pack can use. Do this by adding an extrude modifier to the spline and using a negative amount to extrude it downwards. Then to add thickness, add a shell modifier and increase the inner or outer amount until you get a small strip of land. Finally, you should add a separate plane object to represent sea level, and you can then hide the original terrain so that we can work easily on this small section. It's sensible to plan out your ecosystems in advance. In that way you avoid wasting time modelling or sourcing things that later aren't required. In this scene we're going to keep it quite simple. Along the bottom of the lake bed we'll add some seaweed. Nearer the riverbanks we want some reeds. In fact, we'll add two types of reeds, tall ones that are largely above water level and smaller ones that poke above the waterline and add a little bit of interest. Moving up as we get nearer the riverbank, we want some stones and pebbles that will transition into grass, weeds and finally trees, rocks and flowers. With a plan like this in place, you can easily create a Forest Pack object for each of the distinct areas straight away. For example, here's a step-by-step approach for creating the trees. Create a new Forest Pack object by setting the mode to generate and picking the terrain cross-section object we created at the beginning of this tutorial. Go to the geometry rollout and open the library. Select the objects you want to import. For this example we'll pick a black pine and an American elm model from the new tree library included in Forest Pack 6. Note that you can select and import multiple objects at once by holding down the control button as you click them. Adjust probabilities if necessary. In this example we want fewer American elms, so the probability setting for this model can be lowered to 20%. Now go to the distribution rollout and choose a distribution pattern from the drop-down list. We used Patches 1, one of several new maps included in Forest Pack 6. And adjust the density values until you get the correct coverage of objects. In this case I'm using about 500 meters, but really it depends on the scene and the objects being scattered, so experimentation is a must. You should do the same thing for all the forest objects in your ecosystem plan. To save you from having to watch a lot of unexciting repetition, we're not going to show the creation of every forest object. In fact, throughout this tutorial we'll explain a principle and allow you to apply it yourselves. As you can see, at this stage we didn't worry too much about any of the other settings, only the choice of models, their probabilities and distribution at this point. If you use Forest Pack's built-in presets, like the new layered grass for example, you can probably even just use the default settings. With all the forest objects created, we can restrict them to the elevation range planned in the first tip. This is made possible using the limit by altitude feature found in the surfaces rollout. Using a simple bottom and top value, you can restrict the scatter to a specific elevation range. We'll take this one forest object at a time from the bottom to the top, starting with the seaweed. Open Forest Lister and click the Select All Forest Objects button, and then click the light bulb to hide them. We'll enable the forest objects one at a time. Deselect all the forest objects and unhide the seaweed forest object. At this moment the seaweed covers the entire terrain, but we only want it on the lake bed. To make this happen, go to the Surfaces rollout and enable Altitude Range Limited. Adjust the altitude range bottom value until the seaweed is starting just on the lake bed. You could leave this one because we want the seeds to go all the way down to the bottom of the lake, but by narrowing the threshold so that it closely brackets the actual elevation range of the terrain, you get much more accurate results when you use density and scale fall-off curves, as we'll see later. So for this scene a value of 14 meters worked quite well. Then adjust the altitude range top value until the seaweed is stopping short of the shore. Don't allow it to get too close to the shore or it will protrude through the water's surface. Although a little of this is okay because we can fix it later by editing the scale based on the elevation information. So with those changes done, you should have seaweed that is growing only on the bottom of the lake. Exactly the same technique is used to limit all the other forest pack objects used in this scene to create a complete ecosystem. To help disguise the joins between forest pack objects and make them knit together seamlessly, it's a good idea to overlap their altitude range values. For example, if we enable the forest pack object that adds stones along the shoreline, you can then adjust the bottom value so that it overlaps the seaweed. Similarly, you should use a top value so that the stones overlap the waterline and go up onto the shore a short distance. At this point, we'll enable the main forest objects and turn on altitude range, starting on the lake bed and moving up the terrain. The settings we used in this scene were as follows, but different scenes will of course require their own experimentation. So the seaweed we've already seen, its bottom setting was 14 meters and the top setting was 19.15, just short of the shore. Now overlapping that, we want the stones, which will start on 18.7 meters and then they will go up to 20.2 meters, so a little further than seaweed. In fact, they're going up onto the bank. Then overlapping that, we want the grass, whose bottom setting is 19.98 and the top setting is 25, going some way up into the tree line. And the trees themselves start at 20.6 meters and go all the way up to 500 meters, so that they completely cover the mountains. Notice that each layer's bottom value was smaller than the preceding layer's top value, and that's how we create the overlap. The main parts of the ecosystem are now in place, but the transitions can be a little bit too abrupt. Ideally, we would gradually fade scatters as they overlap, and this can be achieved using Density Falloff, which uses a graph to control the density of the scatter between the top and the bottom altitude range. The graph's x-axis represents the altitude range between the bottom value on the left and the top value on the right. On the y-axis, we have a 0% density at the bottom of the graph and 100% at the top. So for example, this default graph gradually fades the density of the objects to nothing as they reach the top altitude value. Let's take a look at the stones object in this scene as an example. We'd like them to fade as they overlap with the seaweed at the bottom and the grass at the shoreline. So to achieve that, go to the surface rollout and enable Density Falloff. Open the Density Falloff graph. Use the Add Point tool to add 2 points to the curve. Switch back to the Move tool and drag the start and end points down to 0. The density will now gradually fade as it approaches the bottom of the lake and as it overlaps the grass, making the interaction between the two forest objects much more natural. In addition to the stone, you can add the same effect to the grass, the seaweed, and anywhere else you need to disguise a hard, visible line. As well as being able to control the density of the scatter based on elevation, you can also control the scale. This can be useful if you need to change the size of an object based on its altitude. For example, trees often get smaller the higher they are on mountains due to the gradual reduction in oxygen levels, and they're also less diverse and more scattered. In this case, we can also use it to control the size of the seaweed so that it gets smaller the higher it is up the bank to the shore. This will stop it breaking through the water's surface. To achieve this effect, select the seaweed forest pack object and go to the surface rollout. Enable Scale Falloff. Open the Scale Curve Editor. Like the density curve, the x-axis here represents the altitude range between the bottom value on the left and the top value on the right. And the y-axis this time represents scale, 0% on the bottom to 100% at the top. We want the seaweed to be smaller in the shallow water, so adjust the curve's existing endpoint until the plants are no longer protruding above the surface of the water. Now that we have the 4 basic zones set up, the seaweed, the shore, the grass and the trees, you can add more layers to each one to add diversity and interest. The easiest way is often to clone an existing forest object so that some of the work is already done. For example, we can clone the stones and use the style to add the reeds. So select the stones forest object, type Ctrl and V to create a clone, and then go to the geometry rollout and delete the existing items. Add new items. In this case, I'm picking a few third-party reed models, but you could use something else suitable from the library. Go to the surface rollout and edit the altitude top and bottom settings if necessary, as well as the fall-off curves. For the large reeds, we used a top value of 20 meters and a bottom value of 19, but you should eyeball this to get the results demanded by the scene. In fact, in this scene, we've used the same approach to add additional weeds to the grass area, short reeds and long reeds to the shoreline, and small trees and rocks to the trees zone. When you create new layers by cloning an existing forest object, it's important to update the distribution settings. If you don't, cloned forest objects scatter items in exactly the same places. Let's adjust the reeds as an example. Because they were created by cloning the same source, the small reeds and the large reeds share identical distribution settings, so you'll never really see the small ones under the large ones. What we want are overlapping distributions that are hidden and revealed in a believable way. So to fix this, select the forest object that's adding large reeds to the shoreline. Open the distribution rollout, and then select a new distribution map. There are several new maps in Forest Pack 6 that work well for creating layers that overlap and interact with one another in interesting ways. We'll use Patches 2 for this example. Now that we have a pattern that works, it might be necessary to adjust the density as well. In this example, I've reduced the value to 15 meters to add additional reeds. You can also move the distribution map around the scene using the Offset X and Offset Y properties. This is particularly useful if you want to layer two or more forest objects that use the same distribution map and similar densities. You can also rotate the map too for even more variety. Sometimes you get a distribution pattern and density that's working well, but you still want to break up the scatter with more gaps to add another level of randomization and reveal the layers below. The large reeds are another good example of this. The changes we made to the density are working well, but we'd really like some sparser areas with items removed from the existing distribution. A neat way of doing this is to use Forest Pack's clusters feature. Here's how. In the geometry rollout, select existing items and assign them the same color ID. Add a new item to the geometry list and set it to disabled. Make sure it has a different color ID. Now, go to the distribution rollout and change the diversity mode from random to clusters. This mode groups items together based on their color ID. Because we created a disabled item with a different color ID, in effect we're creating gaps in the scatter. The nice thing about this approach is that you can define the size of these groups in scene units. For example, I'm going to create 5 meter groups for the reeds object. To change the shape of these patches, you can use the roughness property. The higher this value, the more irregular the shape of the group. And you can use blurry edges to blend the groups together and noise to add a little natural variation with each group by including items with different color IDs. Repeat this trick to add some interesting interaction to any of the layered objects in this scene. Let's assume at this point that we have all the layers set up on the test terrain and that it's time to add them to the real scene. First, it's important to do some optimization. Several of these objects have had very high density, and applying them to a terrain several kilometers wide is, well, not a sensible idea. There are two easy optimizations that should be applied to nearly any object: camera culling and distance-based fall-off and clipping. Camera culling can be applied to more or less everything. To illustrate, we'll add the trees to the final terrain by unhiding the environment, selecting the trees, and then opening the surface rollout. So now delete the existing objects from the surface list. Click on plus and add the terrain to the surface list. The trees will populate the entire area using the settings that we set up on the small sample landscape. To limit the objects so that they're only scattered in the camera's view, all you need to do is open the camera rollout and assign a camera to the relevant slot. Then enable limit to visibility. Anything that's not visible from this camera's perspective will be removed from the scatter. You can even enlarge the frustum slightly so that items still appear in reflections by increasing the expand property. And if you're planning to render from multiple cameras, enable auto assign to view, and the camera used for clipping will be changed automatically when you switch views. As I mentioned, you should use this feature on nearly every style to optimize your renders. It's applied to everything in this scene. Closely related to this is the ability to clip geometry based on a distance from the camera. With small plants and ground cover, there comes a point where they're so far from the camera that they're not really visible anymore. At this point, it's not worth wasting resources computing them. To demonstrate this feature, we'll optimize the Forest Pack object used to add the grass object. So select the grass Forest Pack object. Because the density of this style is so much higher, this time we'll add the camera clipping before changing the surfaces. So once again, go to the camera rollout and assign the camera. Enable auto assign to active view and enable also limit to visibility. Now go to the surfaces rollout. Remove the existing list and add the terrain. If nothing appears, it's likely the forest is exceeding the maximum number of items allowed. You can increase this using the max density property in the distribution rollout and by adjusting the display settings, but really we need to optimize this scene. There's no way we'll see the grass on this distant horizon, so we should limit to a specified distance from the camera. So to do this, in the camera rollout, go to the far clipping plane property and enter a value of 500 meters. This works well, and it still includes the island in the midground of the render where the grass is still visible. It's also possible to adjust the density and scale of objects based on their distance from the camera. To do this, enable Density Falloff density or scale. You can then use the graphs just like we saw earlier to adjust these properties using curves. The x-axis is the distance from the camera and the y-axis is either scale or density. Do the same thing for all the forest objects, applying camera clipping, limiting the scatter based on distance, and finally swapping the temporary surface for the real terrain. And we're now ready to make a few adjustments to the scatters to cater for other objects in the scene like the buildings and the jetties. So far we've only used altitude information to create these scatters. The final step is to make some more manual adjustments for the composition and the requirements of the scene. These include removing trees, grass, etc. from inside the building. To do this, you can just use a spline that's the shape of the building's footprint and add it as an exclude area to any relevant forest objects. You also need to remove the reeds from the jetties. Fortunately, these are rail clone objects and they already use a spline to define the footprint. All you need to do therefore is to add them as exclude objects to any of the affected scatters, mainly the reeds. We can also use Forest Pack's paint tools to selectively remove parts of the scatter and improve the composition. An example of this is the reeds, where we've removed some of the taller ones from the bank right in front of the camera. To do this, you'd go to the areas rollout and add a new paint area. Set the mode to exclude, then open the brush settings and increase the size of the brush, something between 5 and 10 meters is okay. Click the button to activate the paintbrush tool and just paint in the viewport to remove items. We'd also add some trees using the item editor mode to cast some shadows in the foreground just to the left of the camera. And finally, some flowers have been painted in the foreground area to add a little interest. We did this using the same painting tools, but this time the mode was set to include. In total, 11 forest objects were used in this scene, including seaweed at the bottom of the lake, a shoreline consisting of 2 types of reeds and stone, 2 layers of grass, some large rocks with flowers and tall weeds, and finally saplings and mature trees. That is a lot of layers, but they've all used a combination of the tips explored in this tutorial to populate and optimize a scene automatically based on the elevation of the terrain. This is a really powerful technique for quickly fleshing out environments, even if a little manual adjustment is required later. Best of all, if we were to change the terrain, perhaps by sculpting a second island or changing the shape of the shoreline, the system would automatically adapt to the new landscape. And thanks to camera clipping modes, the view can also be changed and the scene will be re-optimized accordingly. Thanks for listening. Please stay tuned for the next tips and tricks installment and check out our other videos on the tutorial section of the website. And remember, if you use any of these tutorial files or the techniques shown in this tutorial for your own work, we'd love to see it on the forum.